Hope you are fine at home. Last classes we were discussed about rational numbers. That means addition of rational numbers and its properties, subtraction of rational numbers, multiplication of rational numbers and division of rational numbers. And also we discussed number line, how to draw number line, number line of rational numbers, and how to insert rational numbers in between two numbers. These we discussed previous classes. And the properties, that is closure property, commutative property, associativity, identity and inverse for both addition and multiplication. We learned properties of addition and properties of multiplication. Properties of addition. Do you remember the properties of addition? Properties of addition means first one is closure property. What do you mean by closure property? If we add any two numbers or two rational numbers, the answer is also a rational number. Okay, if we add any two rational numbers, then the answer is also a rational number. Again, what is commutativity? Suppose A and B are any two rational numbers. A plus B is also equal to B plus A. A plus B is also equal to B plus A, or A by B plus C by D is also equal to C by D plus A by B. That means we can change the order of addition. Change the order of addition. Again, third property means associativity. If three rational numbers A by B, C by D and E by F, three rational numbers we can add in any order, that is A by B plus C by D within bracket plus E by F is also equal to A by B plus C by D plus E by F in another bracket. Both are equal. And additive identity. What do you mean by additive identity? Additive identity means it is 1. Okay, additive identity of a rational number is 1. And additive inverse means, what is the additive inverse of A by B? Additive inverse of A by B is negative A by B. Negative A by B. And additive inverse of negative A by B is positive A by B. And additive identity, a number plus its additive identity. A number plus its inverse is equal to identity. That is A by B, a rational number A by B plus its additive inverse is minus A by B. You know what is A by B plus minus A by B? A by B plus minus A by B is 0. That is additive identity. That is a rational number and its additive inverse is equal to additive identity. Clear? Now properties of multiplication. Properties of multiplication same way. First one is closure property. If we multiply any two numbers, the answer is also, the result is also a rational number. And commutativity means if A by B into C by D is equal to C by D into A by B. And associativity, A by B into C by D into E by F is equal to A by B into C by D into E by F is another bracket. Both are same. And next property, multiplicative identity. Multiplicative identity is 1. Multiplicative identity is 1 and multiplicative inverse is reciprocal of the given number. Reciprocal of the given number. Suppose A by B is a rational number. Its inverse is B by A. Its inverse is B by A. Okay. No change in sign. Suppose a number A by B, its inverse is Multiplicative inverse is b by a. Multiplicative inverse is always reciprocal of a given number. Reciprocal of a given number. Clear? Reciprocal of a given number. And a number, a rational number into its multiplicative inverse is multiplicative identity. A rational number into its inverse is identity. That means 1. Okay. That is a by b into b by a is what? 1. A by b into b by a is 1. Okay. And one more property is the distributivity of addition over multiplication. Okay. Distributivity of multiplication over addition and subtraction. That is a by b into within bracket c by d plus e by f is equal to a by b into c by d plus a by b into e by f. Clear? A by b into within bracket c by d plus e by f equal to first a by b into c by d, then plus a by b into e by f. Okay. And distributivity of multiplication over subtraction, that is a by b into within bracket c by d minus e by f is equal to a by b into c by d minus a by b into e by f. Clear? And what about the properties of subtraction and division? We didn't learn properties of subtraction and division. Why? Why? Because only closure property is satisfies both division and subtraction. Only closure property is satisfies for division of rational numbers and subtraction of rational numbers. Because if we subtract any two numbers, the answer is also a rational number, you know. If we subtract any two rational number, the answer is also a rational number. That is closure property. And division, if we divide any two rational numbers, the answer is always a rational number. If we divide two rational numbers, the answer is also a rational number. So closure property of division is satisfies, but no other properties, that is commutativity, associativity, identity and inverse, not satisfied or not exist for both subtraction and division of rational numbers. Why? Suppose take commutative property. You just take a number 5 minus 3. What is 5 minus 3? 5 minus 3. We know that 5 minus 3 is 2. 5 minus 3 is 2. 5 minus 3 is 2. Okay, 5 minus 3 is 2. Now change the order. 3 minus 5. What is 3 minus 5? 3 minus 5 is minus 2. Both are different, you know. Both are different. So commutative property does not satisfy. Same way division. In division, 5 divided by 3, which is not equal to 3 divided by 5. Okay, so commutativity property for both subtraction and division is not satisfied. Okay, same way associativity is not satisfied, and identity for subtraction and division does not exist. Identity and inverse does not exist for subtraction and division. Okay, identity and inverse does not exist in subtraction and division. Okay, same way commutative property, associativity are not satisfied for both subtraction and division of rational numbers. Okay, clear? That's why we were not discuss these properties in subtraction and division. Okay. Hope you understand first lesson. Now we are moving to second lesson. Our second lesson is exponents. Our second lesson is exponents. What do you mean by exponents? Exponents means, suppose a number, real number, x into x into x into x n times can be written as x power n, that is x raised to n. This is an exponential expression. Okay, here suppose if x is a real number and n is an integer, x is a real number and n is an integer, then x into x into x into etc. x n times, x n time, okay, into n times is equal to x raised to n, x raised to n. Here x raised to n is called an exponential expression. This x raised to n is called an exponential expression with base x. This is base x, and this n is called exponent or power. Exponent or power. Okay, exponent or power n. Exponent or power n. Okay. Suppose 10 square. How to read this? 10 square or 10 raised to the power 2. We already know how to read 10 square or 10 raised to 2. 10 raised to. 10 raised to means 10 into 10. 10 2 times. 10 into 10. Okay. 10 into 10. 10 raised to 2 means 10 into 10. Now what is this? 10 raised to 5. This is read as 10 raised to. 10 is base. What is 10? 10 is called base and 5 is called power or exponent. 10 is called base. Base means here you know base. 10 is called base and 5 is called power or exponent. Power or exponent. Okay. So 10 raised to 5 means, raised means it is repeating, you know, 5 times repeating. 5 times, that is 10 into 10 into 10 into 10 into 10. 5 times. Okay, 1, 2, 3, 4, 5 times. 10 raised to 5 means 10 5 times. Multiply 10 5 times. Okay, 10 into 10 into 10 into 10 into 10. And this is read as 10 raised to 5 or 10 raised to the power 5. Simply we can read it 10 raised to 5, 10 raised to 2, 10 raised to 5. And how to read this one? X raised to m. X raised to the power m or x raised to m. Here what is our power or exponent? Power or exponent is m. M is called power or exponent and x is called base. This x is called base and m is called power or exponent. Okay, x is base. X is base. M is power or exponent. Clear? Okay, then what is this? How to read this one? 100 raised to 3 or 100 cube. 100 raised to 3. 100 raised to 3. How to read it? 100 raised to 3 or 100 raised to the power 3. Here power is 3, you know, power 3. 100 raised to 3 or 100 raised to the power 3. Here what is base? Base is 100 and power or exponent. Power or exponent is 3. Clear? Hope you understand the concept of exponents. You already know what is exponents. 10 raised to 2, 10 raised to 3. We are in physics and all, you are writing that like that way. Okay, 10 raised to minus 11, 10 raised to 10, like that. So this representation is called exponents. Exponents contains a base and a power. A base and a power. Okay. 10 raised to 5. Here 10 raised to 5 means 10 5 times. Multiply 10 5 times, repeat multiplication. 10 into 10 into 10 into 10 into 10. Okay. This 10 is called base and 5 is called power or exponent. Power or exponent. Here x raised to m. X is base. M is power or exponent. And read as x raised to m. X raised to m. Okay. Clear. Next, laws of exponents. There are three laws are the laws of exponents with integral power. Laws of exponents. First one is product law. Product law. What is product law? Product means what? Multiplication. Suppose a raised to m into a raised to n is equal to a raised to m plus n. Here a means, here also a, same base. This a is called base, you know. M is power. Here a is called base, n is power. Same base and different powers. Okay, then we can add the powers. Base is same, you know. Then we can add the powers. For example, 5 square into 5 cube. Both are 5, you know. Both the bases are 5. 5 square into 5 cube is equal to, what to do? No change to this base. We can add this powers. 2 plus 3. That is 5 raised to 2 plus 3 is 5. Okay. Suppose the base is same. Example. Suppose the bases are same. Then how to multiply two numbers with the same base? Two exponents or two exponential expression with the same base. With the same base means a raised to m into a raised to n is equal to a raised to m plus n. Just add the powers. Here a, here also a. That means bases are same. Bases are same. So you just add powers. That is m plus n. No change to the base. No need to write the base 2 times and all. You just write only one time the base. Only one time you just write the base. Then add the powers. That is a raised to m into a raised to n. How to multiply? Product law. How to multiply two exponential expression with the same base? How to multiply two exponential expressions with the same base? How? Just add the powers. That's a raised to m into a raised to n is equal to a raised to m plus n. Write the example also. 5 square into 5 cube is 5 raised to 2 plus 3. That is 5 raised to 5. Okay. Clear. And next one is quotient law. Quotient means what? Division. Quotient. Quotient law. Quotient law means if a raised to m divided by a raised to n. A raised to m divided by a raised to n, then how to write? It is equal to a raised to m minus n if m greater than n. That means here first number is always greater, you know. For example, 3 raised to 5 by 3 raised to 2. How to write? 3 raised to 5 minus 2 equal to 3 raised to 3. Okay. Suppose a raised to m divided by a raised to n. A raised to m divided by a raised to n is equal to a raised to m minus n. Here multiplication. Here it is multiplication. Here it is division. That is quotient law. Product law means a raised to m into a raised to n. That is a raised to m plus n. Quotient law means a raised to m divided by a raised to n is equal to, you just write a. Only one time you write a, that is base. Then powers you subtract, m minus n. One condition is there, m is greater. And if n is greater than m, that is denominator. In denominator, one power is there, If that is greater, how to do? A raised to m by a raised to n is equal to 1 by a raised to n minus m. Not m minus n, n minus m. N minus m. 1 by. Take the reciprocal and change the order. N minus m. If n greater than m. Suppose if denominator's power is greater, then how to do? 1 by a raised to n minus m. Okay. Now power law. Power law means, what do you mean by power? Power means a is base and m is power. And one more power is coming. A raised to m whole raised to n. How to read it? A raised to m the whole raised to n. Whole. Whole means this full. Okay, a raised to m the whole raised to n. Otherwise, a raised to m raised to n. Power of a power. A is base and one power is m, and again one more power, that is n. A is base, m is power, and n means one more power, that is power of a power. That is power law. Power of a power. Okay, power of a power. That is a raised to m whole raised to n. How to read? A raised to m whole raised to n. Otherwise, a raised to m raised to n. A raised to m raised to n is equal to a raised to m into n. Just multiply. A raised to m into n. Okay. For example, 6 raised to 3 raised to 2. 6 raised to 3 raised to 2. Power of a power. One power is there here, 3. Again one more power, 2. That is 6 raised to 3 into 2. That is 6 raised to 6. Okay, clear. This is an example. Okay. Now, suppose minus a raised to n. One rule is there, you write it. Minus a raised to n is equal to a raised to n. If n is even. If n is even and minus a raised to n is equal to minus a raised to n if n is odd. N is odd. Okay, that is minus a raised to n is a positive number if n is even. Minus a raised to n is a positive number if n is even. And minus a raised to n is a negative number when n is odd. That means, suppose one example. Minus 2 square. What do you mean by minus 2 square? Minus 2 2 times. Minus 2 into minus 2. What is minus 2 into minus 2? Negative into negative, positive 4. It's a positive number, when n is even. N means power. If the power is an even number. If the power is an even number. With a negative base. With a negative base. Base is negative. Suppose when a base is a negative number. Base is a negative number. Then we will look the powers. We will look the powers. If the base is negative, then we will look the bases. Powers. Here power 2. 2 is an even number. Then the answer is positive number. Then the answer is positive number when the power is even. For a negative base. For a negative base. One more example. Minus 3 raised to 4. Minus 3 raised to 4 means minus 3 into minus 3 into minus 3 into minus 3. 4 times, Negative into negative, positive. Positive into negative, negative. Then negative into negative, positive. So the answer is positive. Negative 3 into negative 3, positive 9. Okay, negative 3 into negative 3, positive 9. Again, negative 3 into negative 3, positive 9. 9 nines are 81. Positive 81. Okay, so this is also a positive number, That means when a power is even, 4 is an even number, power is even for a negative base. The answer is also a positive number. That is minus a raised to n is positive number. Positive number if n is an even number. This n is an even number. Again, minus 3 raised to 3. This 3 is, we know that this 3 is an odd number. That is minus 3 into minus 3 into minus 3. Okay. Negative 3 into negative 3, positive 9. Negative 3 into negative 3, positive 9 into again negative 3. 9 3s are 27 and negative into positive, negative. Negative 27 is the answer. So this is a negative number, When you get a negative number, if the power is an odd number for a negative base. Suppose if a negative base with odd power, then the answer is also a negative number. A negative base with odd power, then the answer is also a negative number. And a negative base with even power, then the answer is a positive number. Okay, that is minus a raised to n is equal to a raised to n. That means it's a positive number if n is even. And minus a raised to n is a negative number if n is an odd. Clear? Okay. Write down this. A raised to minus n. If a power is a minus number, then how to do? If the power is a negative number, then how to do? A raised to minus n can be written as 1 by a raised to n. We can make this power into positive by taking the reciprocal. Okay, we can make it into positive. How? By taking the reciprocal, that is 1 by a raised to n. A raised to minus n can be expressed as 1 by a raised to n. And a raised to n also we can express in the form of reciprocal, that is 1 by a raised to minus n. A raised to n means positive power, can be written as 1 by a raised to minus n, that is negative power, by taking the reciprocal. So a positive rational number can be made a negative number by taking the reciprocal. Okay, a positive power can be written as negative power by taking the reciprocal. Positive power can be expressed in the form of negative power by taking the reciprocal, that is a raised to n is equal to 1 by a raised to minus n. Here a raised to minus n, that is a negative power, minus n is a negative number, so a raised to minus n is equal to 1 by a raised to n. 1 by a raised to n. This is positive power, by taking the reciprocal. Okay, so we can say that a raised to n and a raised to minus n are reciprocal of each other. Okay, a raised to n and a raised to minus n are reciprocal of each other. That means a raised to minus n can be written as 1 by a raised to n. Then it is positive, a raised to minus n is equal to 1 by a raised to n. That is, it's become positive power. Again, a raised to n is a positive power, which is equal to 1 by a raised to minus n. Clear? Okay. That's for today's class. Problem section we will discuss on next class. Okay. Many problems are there. Problem section we will discuss on next class, and try to complete first lesson's homework. Okay, all of you try to complete first lesson's homework and also study that lesson. Next week we are going to conduct one TP. Okay, thank you. Have a nice day.
Thank you.